keep the lesson short and sweet today so that you'll have enough time to complete your work. Okay, right, so we're interpreting graphs today. It would be still related to what we discussed last lesson, which is about rates. One of the most popular rates that we know would be the speed. So when you have speed, you'd have many different units of speed, meters per second, right, or kilometers per hour, just like what we discussed last lesson. We want to be able to interpret distance time graphs and understand what information gradients give about straight line segments. We know we're successful if we can write or tell a story that matches a graph. So we'll be doing some writing as well today, creative writing, right? And hopefully your English teachers would be very happy with the work that you'll be handing in for our extension, okay? All right, so let's have a look at our warm-up question there. So this is the journey to the bus stop. Have a look at the graph. What's on the x-axis? It tells us the time, yes. So when you have your x-axis, it's always what you call your independent variable, right? Time is independent of anything we do, right? So time would go on, right, regardless of where we are, regardless of what we do, okay? So time is usually the one that would be on the x-axis, right? Because that would be our independent variable, right? And then you have your y-axis as what? What's described in our y-axis? It's the distance, all right? So when you have your distance there, your 0 there would probably be your place of origin, right? So for example, if you would be graphing your speed going to school, right? Well, right now we can't go to school. Then you would have 0 meters there and then going up to 200 meters, okay? And then you have there the time on the x-axis. So you need to look at as well the units that would be used. So the y-axis would be the distance in meters, and then the x-axis would be the time in seconds. Right, so if you would be figuring out the unit for speed for this one, it would have to be meters per second, okay? So have a look at those graphs there. Describe what may have happened. So you should include details like how fast that person walked, okay? So, and describe whether section A, section B, section C, section D would be realistic. How do you know if it's realistic? Okay, so explain your answer. I'll give you 2 minutes. Let's have a look at that segment A. How far did, let's probably name this person. Any name, any suggestion? Rocky. How about Rocky? How far did Rocky travel in segment A? 100, yes, 100 meters. And how long did it take him to travel that 100 meters? Is it 60? Is it 4? 50. Thanks, Raiden. So 50. So it's 100 meters for every 50 seconds, right? So that was his speed. So remember that 100 meters in 50 seconds. Now let's have a look at, maybe let's skip, yes, thank you, Seth. So that's 2 meters per second. How did you work that out? So 100 divided by 50, right? So 100 meters divided by 50, because how do we figure out the speed? Speed, the formula for that would be distance over time. All right, so speed would be equal to distance over time. What does distance over time mean? It's distance divided by time, right? That's why for the speed of segment A, the speed would be 100 over 50. And what's 100 divided by 50? That's 2 meters per second. Our segment C, which one do you think he went faster? Was it in segment A or was it in segment C? And how do you prove that? The line says that they traveled more distance in less time. Yep, so with segment C, we can say that how far did Rocky travel? So at 40, distance 40, he went to distance 160. What's the difference between them? 120. So the speed now is 120 divided by, from 70 to 100, that's 30 seconds. Thank you. So 120 divided by 30 is 4 meters per second. So obviously this one here would be faster, right? Because your speed is higher, right? Now, by just looking at the graph, how do you know it's faster without these calculations? So when it's more steep than the other, then even without calculations, we can say that C would be faster, right? And then what do you notice about segment D? Yes, so he did not move at all, right? Because there wasn't any change in the distance, but there was a change in time, right? It's flat. So flat is horizontal, right? Not moving. 0 meters per second, right? He wasn't traveling at all, right? Now, why did I skip B? What happened to B? B is a decline. What happens when it declines? He went back, right? Because then remember, this is a journey to the bus stop. So how far is his house to the bus stop? 160 meters, that's right. So the bus stop would be 160 meters away from his house, right? So why do you think that would be going back? Did he actually go back to the house? No. So what do you think happened then? What? So he thought he forgot something, but then he remembered. He put it in another pocket in his bag, correct? So those could be some of the scenarios, right? Or maybe at that time, his mom rang him and said, you forgot your lunch, but then realized that he's already got it in his bag or something, right? So he didn't actually end up going back to the house, right? But it would be halfway through, right? No, not halfway, but nearly to the house, yeah? And then what do you think happened in segment D? Why was it flat? He would have to wait for the bus, and that's why he wasn't moving. Yeah, so those are maybe some ideas how you would be able to construct your paragraph. I also liked the explanation of Umang. He said he maybe dropped something on the way and then he found that on the ground. So he dropped his keys, he dropped his wallet, and luckily he traced back where he went, okay, and got it. All right, now this time we'll probably look at matching. Let's have a look at this graph here. So maybe some of you don't have any idea yet how they would be constructing their paragraph for the warm-up activity. So hopefully this would give you a bit of a clue or a hint as to how you'd start your story. Right, have a look at the graph, have a look at each of these stories. Which one actually matches the graph? Okay, so I've got 4. Is there a D? Daniel, did you change your answer from C to D? What is D? Oh, did you have a different answer other than this one? You would have many different possible answers, right? Depending on how you'd want to create this graph. So it says there, C, Tom went for a jog. At the end of his road, he bumped into a friend and his pace slowed down. When Tom left his friend, he walked quickly back home. How do you know that he slowed down on the second segment? So we're looking at C, and C seems to be the right answer here because the second line is not as steep. That's right. Okay, so we know that he went back because the distance there went back from the top going to your horizontal. So when it approaches the horizontal, that means it's going back. Or you could also say that when the line would be leaning to the left, then that means that person or that object would be going back to its origin. Let's probably dissect each of the segments there. Some of you might not need this anymore, but we'll just have a look at what it says. It says a graph may end up looking like this. So Tom starts from home, right? So that's where you've got your corner there, right? And you would have their line is not too steep. This means Tom slows down. And then you've got that point there, the corner, the peak, that would be the furthest that Tom gets from home. And then the negative slope. So when it's leaning to the left, you have a negative slope. So when you have a negative slope, that means Tom is walking back to his house, right? And then when it reaches the horizontal, then that means Tom is back home, okay? Now, let's have a look at this one here. What's wrong with this graph? Okay, so for sure, he can't teleport. How do you know that he is actually teleporting here, Daniel? Why? How? So we know we can have a horizontal, but why can't we have a vertical? If the line is straight up, then that means they just traveled a bunch of distance instantaneously, right? So that means there wasn't any time lapse, but he went from one distance to the other. You can't be in two places at one time. All at the same time, you are at those distances, right? And you can't have that. Well, you can have that on Zoom maybe, but not in reality, right? So that's why when you have a vertical line, that means that's non-existent in our distance time graph. Does that make sense? Yes? So let's probably recap. When you have a line that's going to the right, it would be moving away, right? The less steep you have for your line, then you would have your speed slower, right? The steeper it goes, the faster the speed is, right? Now, when you're at the peak of that graph, that means that's the longest possible distance that that object traveled, yeah? And we did say that when it's horizontal, that means that object is not moving. The time is still going, right? But that object is going nowhere, right? Then when you have a line that's leaning to the left, right? When it's leaning to the left, then we know that it's going back to its origin, yeah? When it touches that horizontal, when it touches that, like that, right? That means that that object went back to its origin. We can never have any vertical lines. Any vertical lines are non-existent in the distance time graph because we cannot teleport. Okay, you can't be in two places or more than one place at one time. I'll be staying online for your questions. You can message me on Google Classroom. You can also drop in your questions on our Q&A live document. Okay, see you all. Stay safe, stay awesome. Bye. Come on, Rocky, let's go.